Hi folks, in this second video we're going to see how we can draw ray diagrams for a concave mirror. So here I know the mirror is concave because the object is placed on this side, so when it's curved inwards, and we see here we've got the center point that's indicated. Okay, now again, normally I would ask you to do this with only 2 rays, but I'm going to try doing it with 3. Okay, and what we want to try to avoid doing when we have a curved mirror is using our protractor and trying to deal with normals, because it's tough to draw the normal on a curved mirror. Okay, a little more complicated than drawing it on a plane mirror. Okay, so let's get started. First thing we need is, if we need at least 2 rays, we know we're going to have to work with the focal point. So the first thing I'll do is measure the focal point. So here, go from the center, and the focal point is halfway. So 1, 2, 3, 4.3.5. Okay, so we know it's going to be about just under 2.2. Okay, so here we got 1, 2, and it should be just before 2.2. So it should be right there. Okay, so we want to try to be as accurate as possible with our focal point. Okay, so that we get a good diagram. Okay, so let's start with our rays now. Okay, so the first ones I'm going to work with are the ones that involve the focal point. Okay, and there's 2 that involve the focal point. So we know that if a ray goes directly at the mirror parallel to the principal axis, so here I'm going to notice how I use my numbers to try to line this up nicely. So if I have a ray that goes to the mirror parallel to the principal axis, this is going to be reflected through the focal point. Okay, so let's try to get that as good as possible. Do a little more. Okay, and that's going to go through the focal point. Okay, there's my reflected ray. Okay, now the other one that involves this focal point is if I have a ray that starts at the tip and goes through the focal point, it's going to reflect parallel to the principal axis. Okay, so again, you try to go as much as possible through the middle of these points. Okay, and here, so if our incident ray goes through the focal point, it's going to come out. And again, let me turn this around so I can try to use my numbers or the line on the, see, now I'm using this line here on the ruler to help me draw a parallel line. Okay, so there we go. And here we have the intersection of the 2 points. Okay, now not surprisingly, because the object is between the center and the focal point, I should know that the image is going to be further behind the object and that it should be larger. Okay, now let's try now finding the one using the center. So anything that goes through the center, okay, is going to reflect right back, because the center automatically creates a 90-degree angle to the mirror. Okay, so if I start at the center, okay, and something that starts, at the tip of the candle here, that's coming from the direction of the center, we know is going to reflect right back in the same direction. Okay, and so here, reflect right back in the same direction, a little off there, and we see that they intersect at this point here. Okay, so what this dot represents is the reflection of the tip of the candle, okay, behind the object. Okay, and we know that the bottom of the candle is going to have to be reflected somewhere, or its image is going to have to be somewhere along this principal axis. So just knowing this one point, I can now draw my image. Okay, and if I was trying to describe the salt characteristics, we see that the size, well, of the image is larger. Okay, the attitude is reversed. Okay, right side up, upside down. Okay, the location, it's located further away than the object from the mirror. And the type, well, it's a virtual image because we have actual light rays that are intersecting. Okay, So like I said, normally I'll just ask for 2 of these 3 rays, so you can just choose whatever you find more comfortable to work with. Okay, that's it for this one.